In early July, astronomers detected an unusual object moving through our solar system. Named 3I/Atlas, this celestial body appears to originate from outside our solar neighborhood, making it only the third known interstellar object observed by humanity, following the discoveries of Oumuamua in 2017 and Borisov in 2019. Initial calculations suggest 3I/Atlas is on a highly elliptical trajectory, arriving from the direction of the Sagittarius constellation and traveling at a speed of approximately 135,000 miles per hour. Its path brings it toward the inner solar system, with the closest approach to the Sun expected on October 30th, at a distance of roughly 130 million miles, just inside Mars' orbital range. Fortunately, the object will remain distant from Earth, passing no closer than 150 million miles. What makes 3I/Atlas especially intriguing is its apparent size and brightness. Based on current observations, it may be between 12 and 14 miles in diameter, significantly larger than Oumuamua, which was estimated to be about 100 meters long. However, this size estimate depends heavily on assumptions about the object's reflectivity. A dark, solid asteroid might reflect only a small fraction of sunlight, making it appear dimmer, while a more reflective, icy surface would create a brighter appearance and suggest a smaller core. Many astronomers consider 3I/Atlas to be a comet, made of ice and dust. As comets approach the Sun, their volatile materials sublimate, releasing gas and dust that form a glowing envelope or coma. This process can dramatically increase the amount of reflected sunlight, which could explain why 3I/Atlas appears so bright from Earth, even though it remains hundreds of millions of miles away. Still, the object has prompted alternative theories. Physicist Professor Avi Loeb, known for his interest in unusual cosmic phenomena, has expressed skepticism regarding the natural explanation. He argues that if 3I/Atlas is indeed as large as current estimates suggest, it would be statistically improbable for such a body to appear without prior detection of many smaller interstellar objects. According to Professor Loeb, previous research suggests that for every object the size of 3I/Atlas, there should be millions of smaller ones. Yet, only 2 other interstellar objects have been detected to date. This rarity, combined with the object's high velocity and inward trajectory, leads him to propose that 3I/Atlas could be the result of an artificial origin, or at the very least an unusual natural phenomenon not yet fully understood. Loeb further highlights a mass discrepancy in his analysis. If astronomers assume that similar large objects are uniformly scattered across the galaxy, the total mass implied by their presence would be extraordinarily high, approaching a quarter of the total stellar mass of the Milky Way. Given that only a small portion of stellar mass consists of the heavy elements necessary to form rocky objects, this figure seems implausible. Despite these theoretical concerns, most astronomers continue to interpret the available evidence as consistent with a natural comet. Observations from major observatories, including the European Southern Observatory's Very Large Telescope, suggest surface reddening, a characteristic often associated with dust particles. Additionally, some long-exposure images appear to capture a faint coma trailing the object, further supporting the cometary hypothesis. However, Professor Loeb remains cautious. He notes that such features could result from observational artifacts, especially considering the object's speed and distance. He emphasizes that no direct signs of gas or dust emission have been conclusively observed so far. For him, the question remains open. As 3I/Atlas travels closer to the Sun in the coming months, astronomers expect to gather more detailed data. If it is indeed a comet, its approach should intensify solar heating, leading to more visible outgassing. This process would offer definitive proof of its composition and nature. On the other hand, a lack of such activity might lend more weight to alternative explanations. For now, 3I/Atlas remains a subject of scientific curiosity and careful observation. Whether it turns out to be a common interstellar comet or something more unusual, its presence offers another opportunity to expand our understanding of the wider cosmos.